You know that white foam cup you get your coffee in? Or the block that's protecting your new TV in its box? We all have a name for it: Styrofoam. But what if I told you that you've probably never, ever actually touched real Styrofoam in your entire life? Yeah, you heard me right. Let's get into the real story. All right, so here's our game plan. First, we're gonna bust that big Styrofoam myth wide open. Then, we'll see how this wild material is actually made from plastic and, well, mostly air. After that, we'll dive into why it's both an engineering miracle and a total environmental nightmare. We'll try to solve the recycling puzzle, and finally, take a peek at the future of foam.
Okay, first things first, we gotta get the name right. Because the word that we all use for this stuff, it's actually for something completely different. So check this out. On the left, that's real, actual Styrofoam. See the little trademark symbol? It's a brand name for building insulation, and it's almost always blue or pink, super dense and great at resisting water. Now, on the right, that's what we think is Styrofoam, expanded polystyrene, or EPS for short. That's our lightweight, white, kinda crumbly friend used for coffee cups and packaging. It's like they're cousins, but definitely not twins.
So, how in the world do you turn solid plastic into this super light, puffy foam? Well, the process is pretty fascinating. Honestly, it's kind of like making giant, industrial strength popcorn.
It all starts with these tiny little plastic beads of polystyrene. In step one, they hit them with steam, and a blowing agent inside each bead just puffs them up, expanding them to many times their original size. Then, they let these little puffy beads just sit for a while to mature and stabilize. And for the grand finale, they pack all those beads into a mold, say the shape of a cooler, and blast it with steam one last time. That heat fuses them all together, and bam, you've got a solid object.
Now, here's the secret, the absolute key to understanding EPS. The final product is more than 90% air. Just let that sink in. That giant block of foam is almost entirely nothing. This one fact explains everything: why it's so light, why it insulates so well, and, as we're about to see, why it's such a massive environmental headache. And what about that little bit less than 10% that isn't air? Well, that's a plastic called polystyrene. It's made from a liquid called styrene, which comes from, you guessed it, petroleum or natural gas. So yep, at its very core, all this foam starts out as a fossil fuel. So this brings us to the real heart of the issue with expanded polystyrene. It's this total double-edged sword. It's an incredibly useful, almost miraculous material, but its very nature also makes it a huge, huge problem for the planet. I mean, let's give credit where it's due. This stuff is an engineering marvel. It's so light and amazing at absorbing shocks, making it perfect for shipping fragile things. It's a fantastic insulator which saves a ton of energy in buildings. It's literally a lifesaver used to transport temperature-sensitive medicines and vaccines. And because it floats so well, it's used in docks and buoys all over the world. It's not easy to replace. But then there's the other side of the coin. It's an environmental menace. Because it's so brittle, it breaks apart into those tiny little white beads that just go everywhere. They pollute our oceans, our rivers, our landscapes. Animals mistake them for food, which is just tragic. And because it's plastic, it doesn't really biodegrade. Those little bits can stick around for hundreds, maybe thousands of years. So there you have it, a material that's both incredibly helpful and incredibly harmful. Which leads us to the really big question: what on earth are we supposed to do with all of it? Now, you're probably thinking, just recycle it, duh. And that makes perfect sense. But that's where this story gets really tricky. Recycling EPS is technically possible, but in the real world, it's a complete puzzle. Here's the #1 reason why it's so hard, and it all comes down to economics. Imagine a giant semi-truck, okay? You can fill that truck to the absolute brim with foam packaging. So it's taking up 100% of the truck's volume. But because the foam is over 90% air, the actual amount of plastic in there, the stuff that has any value, is tiny. You literally spend more money on gas and a driver to haul this stuff than the material itself is worth. The numbers just don't add up.
And if the economics weren't bad enough, there's another killer problem: food. Think about all the coffee cups, the takeout containers, the meat trays. They're all covered in food waste and liquids. Cleaning that gunk off is so difficult and expensive on a large scale that it's just not practical. And that's why almost all of that food service foam goes straight to the landfill.
So, does any of it ever get recycled? Yes, but it's usually just the clean industrial stuff, like the big blocks that packed your new washing machine. They collect that, feed it into a machine called a densifier, which basically squishes or melts all the air out, reducing its volume by like 90%. Then, they can grind that dense block into pellets and use those pellets to make totally new things, like picture frames or coat hangers.
So, given that recycling is such a nightmare, we're at a turning point. We're looking for new ways to deal with this. The future of foam is probably going to be a mix of new laws, new tech, and some really cool, entirely new materials.
This chart kind of lays it all out for us. Right now, we've got solutions like just banning the stuff outright in some places, plus the mechanical recycling we just talked about. Then you've got this wild emerging tech, things like chemical recycling that can break the plastic all the way back down to its original liquid form, and even, get this, mealworms that can literally eat and digest it. And finally, we're looking at replacing it completely with alternatives like molded paper pulp or foam that's actually grown from mycelium. That's the root structure of mushrooms. How cool is that? And really, this quote just nails it. The whole story of Styrofoam isn't just about foam. It's a perfect symbol for our whole relationship with modern plastic. We've gotten so good at designing these amazing materials for convenience, but we completely forgot to design the systems to deal with them once we're finished. And that leaves us with this final massive question to chew on. As we look at things like chemical recycling and plastic-eating worms, are we betting that technology will eventually save us from the problems our materials create? Or is the real answer to fundamentally change the materials we decide to use in the first place? It's something we're all going to have to figure out.